Hey, sixth graders, welcome back. I just want to go over this lesson 4 with you. It shouldn't take us very long because it's on comparing and ordering. And we kind of talked about what all the symbols mean already. So remember, that's the greater than symbol. Remember I told you on a number line? Let me just make a number line real quick. This is literally the greater than symbol. The farther I go right, the greater the number gets. This one is literally your less than symbol, okay? The farther you go left, less than. That's where those symbols come from, I think. Okay? Equal to, we know what equal is. All right, now there's a couple things that I want you to keep in mind. We know that negative numbers are always less than positive numbers, but there aren't any negative numbers in this part. This is talking about all rational numbers. Rational numbers mean that it's anything that can be written as a decimal, a repeating decimal, a fraction, or a whole number, okay? So it means it can't be like a number like pi where it keeps going 3.14159, blah, 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 okay? So when we talk about, and we're not doing this part, so I'm gonna do some notes down here. So a rational number, it's actually any number that can be written as a fraction, okay? That can be written as a fraction. And you can spell W-R as a fraction. It's important you know that. Okay, that will include, okay, all decimals, positive or negative, okay? All terminating or repeating decimals. Because both terminating and repeating decimals can be written as fractions, okay? All fractions and all whole numbers. Okay? What it doesn't include is numbers that go on forever as a decimal, like pi, okay? Now, when you're comparing them, what you need to do, whole numbers should be pretty easy because you know how to compare whole numbers. So when I'm comparing them, and I'm gonna write this down here too, for decimals, line up the decimals. Stack the numbers and line up the decimals. And I'll show you what I mean. Okay, so for example, on this one, and I'm gonna skip around a little bit, it's 9.02 and 9.2. If I stack them, where my decimal, okay, is the same, in the same place, and then I add as many zeros as I need, it's pretty clear now which number is smaller. 9.02 is smaller than 9.2, okay? So that's how I would know. Same thing with this problem here. If I have 6.050 and I have 6.05, remember you can add as many zeros as you want to the end of a number. They're equal, okay? Those two are equal. So that should be the easy part on there. You line up if you always stack the decimal and then you literally go value by value, okay? This one should be, even if I'd line this up, it's 15. It's 1.5, 15's decimal would be there. We know that 15 is greater than 1 anyway, but if I lined it up, it's going to show it to me that way. Okay? All right, if they're fractions, they're not colors here. What's going on? Here's my green one. You have to find a common denominator. There's 2 ways to do it. Okay? I'm going to show you both. Find a common denominator. Or you can cross multiply. All right, some of them are gonna be easier than others though, okay? And I don't think they're giving you any real hard fractions, or I can look at which 2 numbers, if I have the same numerators or really close denominators, I can kind of see which is what. This is 19 out of 24, this is 19 out of 21. If I did 24 parts and I take 19, These are way closer to 1 than this is, so that has to be smaller. Or if I had a calculator, I could do 19 times 24, which I have no idea what that is right now, and 21 times 19. Let's do it over here. I'll do it quick. 19 times 24. 14, I get 6, 15, 4. So this would be 456. If I did 19 times 21, you always put it up by the numerator. 18. Just doing the multiplication fast for you. This is 399. 399 is less than 456, okay? If I'm doing this, I have 16 17ths, which is real close to each other, and 11 12ths. 16 17ths is, they're both really, really close to 1. But this one's going to be bigger because it's closer. Like there's 17 pieces and there's 16 of them. So that's got to be, all the pieces are a little bit smaller. So if I have 16 of them, it's going to be bigger. I got to sneeze. Maybe not. Thought I had to sneeze. So that one would be greater. Okay, the whole number should be kind of easy. 212, 190. Hopefully we know that one. 212 is greater than 190. And then 12 and 19, right? Here's our problem child. I have 0.4 and I have 9/40. I have to change them to the same thing, okay? So I either have to have both fractions or both decimals. So I can either divide that out or I can write this as a fraction and have a common denominator, okay? So I'm gonna write this one as a fraction because it's easy, it's 4/10, okay? If I wanted to get it to 40th, I'm gonna multiply it by 4. So I know that 4/10, 0.4 is 4/10, it's in the tenths place. So if I times it by 4, I get 16/40. This one was 9/40, therefore that one's bigger. Okay, so there's a lot of different ways you can do it. You just got to figure out which way works best for the problem. Okay, so use this for sure when you're ordering decimals. Okay, all right. On this page, it says use the. Oops, let me move that up. Use each of the following terms at least once to describe or compare the values of M, N, P, and R. Okay, so. Greater than. So I'm going to pick 2 points. What point is greater than another point? So M's my smallest point, N's my second smallest point, P's my third smallest point or second largest point, and that's my largest point. If I want to be very safe, I would say R is greater than P, R is greater than N, R is greater than M. Okay, so there's different ones that I could use for that. Okay, less than. It wants me to use each of the terms once, so I'm going to use N on this time. N has to be less than because it's left on the number line. This is negative, this is positive. So let's say N is less than P because P is farther right. Okay, opposites. This time I got to count it, okay? I've got N is 2 over. There's nothing here that's 2 over, so I can't use N. M is 1, 2, 3, 4, 5 over. 5 from 0. 1, 2, 3, 4, 5 from 0. They're both 5 from 0. That means they're opposites. So M and P are opposites. So both are 5 units from 0. I don't know that it's 5 necessarily because I could be going by 2s or I could be going by 4s, but it doesn't matter because if I went by 2s, that would be 10 and that would be negative 10, okay? All right, negative number. If this is 0, I could do either M or N. Either. Look at me how spelling today. M or N have to be negative. Okay? Does that make sense, I hope? So just look at your number line. Remember, this way it goes farther positive. That goes smaller negative, the farther you go left. Remember when you have an arrow on it, greater than, less than. All right, it says tell what the value of each point would be if P is 2.5, okay? So I'm gonna do different colors because I'm gonna be writing on my same number line a lot. So this is gonna be my purple one. So let's say this was 2 1/2. That means I have to divide these up into things that would equal 2 1/2. And my guess is gonna be, it's not gonna be 1, but it's gonna be a half. So if this was 1/2, this would be 1. This would be 1 1/2. This would be 2. This would be 2 1/2. That means this would be 3. So I'm going by 1/2. That would be 3. 3 1/2. That would be 4. So R would be 4. So same thing here. I'm going by 1/2. This would be negative 1/2. N would be negative 1. Negative 1 1/2. Negative 2. Negative 2 1/2. And remember we set up here they were opposites. Oh, what were the opposites? M and P. So I could have just looked at that was 2 1/2. So that has to be negative 2 1/2. Okay, so M is equal to negative 2 1/2. Okay, I'm going to do N in green. Okay, so I told you I'm going to be writing on this a lot. If N is negative 0.4, that means this is negative 0.2. This would be 0. Okay, so I'm going by 0.2. And if I think about by 2's, it's really easy because then I'd say that's negative 2, negative 4, negative 6, negative 8, negative 10, but it's a decimal, so it'd be 1, negative 1, because this would be negative 0.6, 0.8, negative 1.0. Okay, so I would keep going that way. If I went to P, this would be, remember I go up by 0.2, 0.2, 0.4, 0.6, 0.8. It's not 0.10, it's 1.0 because that's where my decimal would go. So this would be 1.0. And remember, these were opposites anyway, so I knew that. So P would equal positive 1, and then 1.2, 1.4, 1.6. Okay? All right, let's try this one. If R is 200, okay? So we're saying this guy's 200. Well, he's 1, 2, 3, 4, 5, 6, 7, 8 over. So 4 over would be 100. Does that make sense? So half of that way would be 100. 1, 2, 3, 4. This would be 100. Now, there's 4 in between everything. So I'd have to figure out what is 100 divided by 4, which is 25. So each thing is 25. This would be 50, 75, 100, 125, 150, 175, 200. So I'm just trying to figure out a scale, okay? So if R is 200, that means P is 125. Remember we said that M was P's opposite? So if P is 125, M is the opposite. It is negative 125. So I don't even really have to do anything with that one. I can just figure that out. And then I would look at N. This is 0. Now we're going to go back 25. Negative 25, negative 50. Okay? All right, last one. And then we're done for the day. We're going to use blue. Okay, so it's saying M is negative 15. Okay, think about it. It's 1, 2, 3, 4, 5 units from 0. That means I'm going to divide by 5. So each of these is going to be negative 3, negative 3, negative 6, negative 9, negative 12, negative 15. So my scale for this one is equal to negative 3. Okay, I'm going to put my scale on all of them. I should have done that. My scale on this one, each point on here was 25, right? My scale on this one was 0.2. And then my scale on this one was 1/2. So that means every point was 1/2 or negative 1/2, depending on which way you went. All right, well, if I know M, remember, I know P because they're opposites. So if M is negative 15, P is the opposite. It is positive 15. And I know it goes by 3's. So if this is 15, say 18, 21, 24. So R would be 24. Okay, and then N, I know each one is 3, so I'm going back 3, so that's a negative 3, negative 6. So look at, I did the same number line 4 different times and used a different scale, yet my points are still the same distance apart that they were before. It just depends on what my scale is equal to, okay? So it doesn't always have to be 1. If it's not numbered, it could be 25. But if it's 25 this way, it's 25 this way, okay? So your scales are always consistent. Be consistent, okay? In other words, I can't say this goes up by 25 and say this goes down by 50, okay? I have to be the same distance apart. This is 25, this is 25, this is 50, this is 50, okay? So your scales have to be consistent. All right, it's got your, are you ready for more? So your key points on here, the list of fractions between 0 and 1 look like this. You can put them in order by, see how their denominators are. If the numerators are the same, the denominators are, you're gonna small or big to small. Same thing here, okay? So it's kind of just what we reviewed. Always look these over. It's not on the other side. Always look these over before you do the homework, or keep this with you when you do the homework because it will help you a lot. All right, I hope you have a fabulous day, and I will talk to you all later. Bye.